Fall past the outer edge of a black hole, and what actually happens to you next? Not the fiery, crushing death you might imagine. Something far stranger is waiting inside. It is a place where the ordinary rules of reality quietly stop working, where up and down lose all their meaning, and even your future changes its shape. To understand why, we are going to follow you all the way down into one. And by the end, escape will look as impossible as traveling back into the past. Start with something simple. Throw a ball straight up and it soon falls back down. Throw it harder and it climbs a little higher before gravity drags it home again. But throw it fast enough and it never comes back down to you at all. That magic speed has a name. Escape velocity, the price of leaving a whole world. On Earth, that price is about 11 kilometers every single second. The more mass you cram into a small space, the higher that price will climb. Squeeze a world down small enough, and that price rises past anything you can imagine. Past the fastest thing in the whole universe, past the speed of light itself. And there is the whole secret of a black hole, hidden in a single line. Its escape velocity is greater than light, so light itself can never get out. Anything that falls inside can never climb back out again. Nothing at all can. But how do you crush that much gravity into one impossibly tiny point? For that, you need a dying star and a truly spectacular, violent death. A giant star spends millions of years locked in one enormous, silent battle. Its nuclear fire pushes outward, fighting the crushing weight of its own vast mass. But one day the fuel runs out, and the great fire simply goes dark. With nothing left to push back, the core collapses in a fraction of a second. The outer layers erupt outward in a supernova, briefly brighter than a billion suns. But the core just keeps falling inward, and nothing we know can ever stop it. It crushes down smaller and smaller still, until it seems to vanish altogether. What it leaves behind is a kind of open wound in space itself. From the outside, a black hole is barely even a thing at all. It is a set of invisible boundaries, wrapped in rings around a point of no return. Peel it apart, and you find a genuinely strange anatomy, built up in layers. The outermost layer is the only part you can ever actually see. A blazing, spinning whirlpool of gas and dust, called the accretion disk. Matter spirals inward, faster and faster, squeezed ever tighter as it falls. Friction heats it to millions of degrees, far hotter than the surface of any star. These glowing disks shine as the single brightest objects in the entire universe. A single feeding black hole can outshine an entire galaxy of 100 billion stars. And yet the black hole itself gives off absolutely no light at all. We only ever see the glow of doomed matter, screaming as it falls inward. Move deeper still, and you reach a ghostly shell called the photon sphere. Here, gravity bends space so hard that light itself is forced to travel in circles. Photons orbit the darkness in tight loops, like tiny moons made of pure light. If you somehow stood here, you might glimpse the back of your own head. Light leaving the back of your skull loops all the way around, into your eyes. But keep falling, and you reach the most famous boundary in all of physics. The event horizon, the one true point of no return. It is not a wall and not a surface. You would feel nothing as you cross. There is no sign, no barrier, and no warning of any kind at all. Yet crossing it is the most decisive, single act possible anywhere in the universe. Because once inside, every path and every direction leads only ever deeper in. The size of this boundary has a name too, the Schwarzschild radius. And the truly strange part is just how astonishingly small it can be. Crush our entire sun into a black hole, and its horizon would be tiny. just 3 kilometers across. A whole blazing star, shrunk to the size of a town. Crush our whole planet Earth the same way, and it would be smaller than a marble. For 100 years, all of this was only ink and mathematics on a page. Nobody had ever actually seen a black hole. Perhaps nobody ever truly could. Then, in 2019, humanity managed something genuinely extraordinary. Telescopes across the whole planet linked together into one single Earth-sized eye. They aimed it at a galaxy called M87, 55 million light-years away. And they captured it, the first real image of a black hole ever taken. A dark, round shadow, ringed by a glowing halo of superheated, twisted gas. The silhouette of an object from which nothing can ever come back. That black hole was a monster, 6.5 billion times our sun's mass. These giants have a name of their own, supermassive black holes, and they hide everywhere. Almost every large galaxy has one lurking silently, deep down in its center. Even our own Milky Way quietly spins around a hidden giant of its own. It is called Sagittarius A star, 4 million times the mass of our own sun. But even that giant is dwarfed by the true titans out in the deep cosmos. The largest hold tens of billions of suns, growing wider than our whole solar system. So what would it truly feel like to fall right into one of these giants? Let us stop watching from a safe distance and finally take the plunge ourselves. The answer depends on one brutal force, the terrible stretching pull of gravity. Gravity always grows stronger the closer you get to a heavy mass. So as you fall feet first, your feet are pulled harder than your distant head. Near a small black hole, that tiny difference becomes utterly, unimaginably monstrous. The pull on your feet can be thousands of times greater than on your head. Your whole body stretches into a long, thin strand. Scientists call it spaghettification. For a small black hole, this tears you apart long before you even reach it. But a supermassive giant is far gentler at its edge, and that changes everything. Around one of these, you could cross the horizon completely whole and still alive. So let us fall into a giant and actually survive the crossing itself. But now something genuinely bizarre begins to happen to time itself. Gravity does not only bend space around it, it also bends the flow of time. The stronger the gravity, the slower time ticks, and here that effect is overwhelming. To a friend watching from far away, your fall looks impossibly, eerily strange. They see you slow down and then freeze, hovering forever right at the edge. Your frozen image reddens, dims, and slowly fades, but it never quite disappears. To them, you hang frozen at the horizon until the very end of time. But from your own point of view, nothing strange seems to happen at all. You do not freeze, you do not slow, you simply fall straight on through. Two truths, both completely real, separated forever by that one invisible line. And now you are inside. Behind you sits the point of no return. You look back, fully expecting to see the bright exit you just came through. But there is no exit, and this is where reality itself turns completely inside out. Outside a black hole, you can move freely through space, but only forward through time. You cannot ever choose to stop tomorrow from arriving. Time only flows one way. Inside the horizon, gravity is so extreme that space and time simply trade places. The direction toward the center is no longer a place that you can ever avoid. It becomes a direction in time. The center quite literally becomes your future. So escape is not merely difficult or unlikely. It is a plain logical impossibility. Fleeing the center would be like trying to fly backward into yesterday. You simply cannot. No rocket, no engine, no imaginable speed could ever possibly be enough. because you are no longer fighting a force, you are fighting the direction of time. And so, exactly like every tomorrow, the center draws steadily, quietly closer. That center is called the singularity, and it is the deepest mystery of them all. Our equations say all the mass is crushed down into a point of zero size, a place of infinite density, where gravity itself climbs endlessly toward infinity. And this is exactly where we have to be completely honest with you. The truth is that we genuinely do not know what happens down there. At the singularity, every known law of physics we have simply breaks apart. Our finest theories return only nonsense, infinities that surely cannot be real. It marks the exact edge of all human understanding, a question mark at the core. So this, at last, is what truly waits inside a black hole. Not a pit that you fall down, but a future that you cannot escape. The moment you cross that line, the center stops being a place ahead of you and becomes a time you can no more avoid than your own inevitable tomorrow.